Recently, scientists have been asking some big questions about our universe. They're wondering if everything we thought we knew about how it all began might be wrong. The James Webb Space Telescope, an incredible piece of technology, is challenging our understanding of the cosmos by spotting things we didn't think were possible. For instance, it has discovered ancient galaxies that are surprisingly large and fully formed just a few 100 million years after the Big Bang. This discovery has thrown a wrench in our timeline of how galaxies are supposed to evolve. Additionally, there's a star called Methuselah that appears to be an astonishing 15.36 billion years old, even though we believe the universe itself is only 13.8 billion years old. This raises the question, could the universe be older than we thought? Or is there something important missing from the Big Bang theory that explains how everything started? The James Webb Space Telescope is not just a marvel of engineering. It's a groundbreaking tool that is rewriting our history of the universe. With its impressive 6.5-meter mirror, this $10 billion observatory can even detect the heat of a bumblebee on the moon from Earth. It's shining a light on a time right after the Big Bang, revealing cosmic structures that surprise even the experts. As Webb looks further back in time and deeper into space, it's becoming clear that the universe might be much weirder and older than we ever imagined. Even great minds like Albert Einstein made mistakes in their understanding of the universe. At one point, he believed the universe was static and unchanging, so he added a concept known as the cosmological constant to his equations. When he found out the universe was actually expanding, he removed it, calling it the biggest mistake of his career, only for that same idea to be revived later to explain how the universe is speeding up. Despite all the twists and turns in our scientific journey, most scientists still agree on one key idea, that the universe began about 13.8 billion years ago with the Big Bang. But this event wasn't just an explosion in space. Rather, it was like space itself suddenly grew, bringing time and matter into existence from a dense, hot point. But how can we be confident about such an ancient moment that we can't directly observe? By looking at how the universe has expanded over time and tracing it backward, scientists can reach a point where everything was compressed into an incredibly tiny, dense state. In essence, our understanding of the universe is evolving, and with the help of powerful tools like the James Webb Space Telescope, we're unveiling mysteries that could change how we see everything. The singularity that catalyzed the formation of our universe, what many refer to as the Big Bang, marks a profound moment in cosmic history. Yet the real smoking gun that provides evidence for this explosive genesis is the cosmic microwave background radiation. This faint, omnipresent glow permeating the cosmos is a remnant of the primordial heat that lingered just after the Big Bang, a time when our universe was a dense, hot soup of particles. Its nearly uniform distribution across the night sky serves as one of the most compelling pieces of evidence supporting the theory of the universe's expansive birth. According to prevailing cosmological models, the initial galaxies emerging during this epoch were anticipated to be small structures, still in the process of formation within the young universe. Previously, astronomers estimated that the first stars began to shine approximately 200 to 300 million years following the universe's inception. The mechanisms by which these primordial stars coalesced into galaxies and the rapidity of their evolution have remained some of the most perplexing mysteries in astrophysics. However, groundbreaking observations from the James Webb Space Telescope, JWST, have begun to shake the foundations of these long-held beliefs in ways that were entirely unforeseen. Initially, the images captured by Webb aligned with the expectations, revealing faint, small galaxies dating back to 300 million years post-Big Bang, low in mass and still in their early galactic infancy. But the narrative took a dramatic turn when astronomers identified 6 galaxies from this primordial era that were not merely nascent structures, but rather impressively massive, rivaling the mass of our own Milky Way. This revelation is not just unexpected, it poses a formidable challenge to the core assumptions underpinning modern cosmology. Astrophysicist Ivo Labb, a key member of the research team analyzing these remarkable Webb images, recounted his astonishment at the findings. He ran the analysis software, and it spat out 2 numbers: distance 13.1 billion light-years, mass 100 billion stars. "I almost spit out my coffee," he disclosed. These galaxies, which emerged inexplicably early in cosmic history and possess an astonishing mass, should not exist according to our current theoretical framework. Labb and his colleagues based at Swinburne University in Melbourne meticulously focused on deep-field images captured in a region of the sky near the Big Dipper, an area that had been the subject of earlier study by the Hubble Space Telescope. However, Webb's advanced near-infrared NIRCam revealed an intense tapestry of reddish glimmers, indicative of the unfathomable distances involved. By calculating the redshift of the light emitted by these galaxies, scientists deduced that the light had traveled over 13 billion years to reach us. In essence, we are witnessing ancient cosmic giants that existed at a mere 500 to 700 million years after the Big Bang. This discovery has thrown a wrench in our timeline of how galaxies are supposed to evolve. Contrary to expectations that these galaxies would be small and inexperienced cosmic toddlers just beginning their stellar formation, they are instead revealed to be massive, fully developed entities brimming with stellar activity. Their very existence compels us to reevaluate the timeline regarding the formation of structures in the early universe and suggests that we may have been interpreting the cosmic narrative from the wrong chapter all along. The data unleashed by the James Webb Space Telescope is undeniably revolutionary, leaving the scientific community grappling with new questions about the evolution of our universe. All 6 of the ancient galaxies detected by the James Webb Space Telescope possess stellar masses exceeding 10 billion solar masses, with one potentially nearing the staggering 100 billion mark. Such substantial mass is typically indicative of mature galaxies akin to our Milky Way, rather than primordial structures emerging a mere few hundred million years following the Big Bang. This raises a perplexing question. How could these colossal galaxies have formed so swiftly in the cosmic timeline? Current models suggest that the amount of normal matter in the early universe was insufficient to support such rapid galaxy formation. To reconcile these findings, one potential explanation posits that the density of matter in the nascent universe may have been 2 to 5 times greater than established theories predict. Alternatively, we could be witnessing a phenomenon of galaxy formation that is entirely unprecedented, necessitating a completely new framework of understanding in cosmology. This poses a significant challenge to our existing cosmic narrative. Enter Rajendra Gupta, an astrophysicist from the University of Ottawa, whose team has proposed a groundbreaking hypothesis that could fundamentally alter our understanding of the universe. Gupta suggests that the universe may be much older than the widely accepted estimate of 13.8 billion years, potentially as much as 27.6 billion years old. According to Gupta, the peculiar findings emerging from Webb's observations are not mere anomalies, but rather critical clues hinting at a far more complex truth about the universe's infancy. The evidence continues to accumulate. After the detection of the original 6 ancient galaxies, Webb has identified additional enigmatic objects, including the recently reported Big Wheel galaxy, a massive entity with a stellar mass nearly 5 times that of the Milky Way. Its characteristics suggest an age so advanced that it starkly contradicts established notions of early cosmic structure. Additionally, there's the perplexing Methuselah star HD 140283, located in the constellation Libra. Current estimates place its age between 13.66 and 15.36 billion years, making it plausibly older than the universe itself as per the 13.8 billion year timeline. This scenario poses a philosophical quandary. How can a star exist that appears to predate the universe we know? If any of these celestial objects genuinely predate the universe's current age, it would compel a fundamental reevaluation of the Big Bang Theory, or our interpretation of it. These revelations provoke the question, what if the universe did not originate in the manner we have long thought? What if our understanding merely grazes the surface of a much deeper, more intricate cosmic history? While some might hastily conclude a cosmic contradiction exists, it is essential to consider measurement uncertainties that scientists acknowledge. Typically, there is a margin of error of about 30% in age estimations of astronomical objects. Most estimates for the Methuselah star's age still align within the generally accepted timeline range, despite the emergence of some conflicting estimates. Recent analyses suggest that it could indeed be significantly younger than previously believed. Nevertheless, Rajendra Gupta and his team remain skeptical of the traditional timeline. Their controversial assertion posits that the universe's inception did not occur 13.8 billion years ago, but rather at approximately 26.7 billion years ago. They focus their argument on redshift, the key metric utilized for determining the universe's age, suggesting that our current methodologies may need substantial reevaluation. Gupta has pointed out some important gaps in our understanding of how the universe works. He believes that current models don't take into account certain important factors called coupling constants, which explain how particles interact with each other. If these factors can change over time, as Gupta suggests, then the process of forming the early galaxies we observe with the James Webb Telescope might have taken a lot longer than we thought, possibly billions of years instead of just a few hundred million. This extended timeline could help answer some of the biggest questions we've had about those massive galaxies. But Gupta isn't just focused on galaxies. He's also suggesting that we need to rethink our understanding of dark energy, which is the mysterious force that's been thought to be pushing the universe apart and making it expand faster. Interestingly, some new studies indicate that dark energy may not be a constant force after all. It could actually be getting weaker over time. This new perspective raises more questions about our current models of the universe and could reveal even more gaps in our understanding of how everything fits together. Catch you next time.